in some of the earlier videos, I gave you something like this. Me picking out a one card from a packet of cards. What is the probability of it being a heart, or a jack? So here there's an overlap. So there's an overlap. So when there's an overlap, we have to jump to a Venn diagram because we can't count this jack twice. Okay, so if you don't understand what I'm talking about, watch some of the earlier videos. So when there's an overlap, just jump to a Venn diagram. So here's another example of an overlap problem. So you've got to jump to a Venn diagram. So let's say there are 20 people. There are 40 people in your class. 32 are able to swim, 29 are able to ride, and there's no one who can't swim or ride a bike. So there's no one who can't swim, can't ride. Okay, they must be able to do one or both. Okay, so here, and then I would ask you, what is the probability of me picking someone at random from your class who can swim and ride a bike? I'm going to use this symbol for and. Okay, this symbol here is and then I'm going to use this for or. Okay, so here I'm going to pick someone at random from your class of 41 people. Okay, what is the probability of that person being able to swim and ride a bike? And then I'm going to ask, what is the probability of me picking someone out at random and that person being able to swim or ride a bike? So if that person can swim, then that's a good outcome. If that person can ride, then that's a good outcome. Well, swim or ride, okay? And then I would ask, what is the probability of me picking out someone at random and that person not being able to swim? Okay, so here at the moment it's hard to answer this question because well, given this information here, it's hard to answer that question. So jump to a Venn diagram. So hang on. So learn to draw a Venn diagram, because once you've got your Venn diagram, it's a lot easier to see what's going on. So here this here will represent swim. Okay, swim, and this here would represent ride. Now there are 32 people who can swim. So 32 here, and there are 29 who can ride. 29. Okay, now if you get 32 plus 29, that becomes 1, 5, 6, 61. But the thing is, there are only 40 people in your class, and this is 61. But there are only 40 people in your class, so it must mean that there must be people who can both swim and ride a bike. So basically, hang on. Let's get 61. Take away 40. So this will be 121. The thing is, there will be 21 people who can ride and swim. So originally there were 32 here, and 21 will move into this intersection of the two. This overlap. Okay. So 30. There were originally 32, but then 21 moves into there. So hang on, 32, take away 21. So this would be 1, 1. So hang on. So there are only 11 people left on this side here. Now originally there were 29 and 21 moves into there. So there must only be 8 left. Hang on, 8 over here. Erase. Hang on, bear with me. So this is our Venn diagram now, and we're told that if you look at this here, what's inside the circle here represents people who can swim. Okay, so on the outside of the circle here, it represents the people who can't swim. Okay, and if you look at this Venn diagram, everything inside this circle represents the people who can ride a bike. Everything inside the circle, and anything on the outside of this circle here represents the people who can't ride. Okay, and the thing is, everything inside here represents the people who can both swim and ride. Okay, but look at this original piece of information here. 0 people who can't swim, can't ride. Well, can't swim, can't ride would be this. Well, can't swim, can't ride would be this area here. Okay, so our Venn diagram would look like this. Can't swim, can't ride would be 0 out here. So this is our Venn diagram now. We can now answer the question. We can now with this Venn diagram we can easily answer this question now. What is the probability of me picking someone from this whole population here, from your class? What is the probability of me picking one person from your class who can swim and, let's say, and ride? Well, swim and ride. Well, if you look at this here, swim and ride would be this bit here. What's inside here? This is swim. Anyone inside here can swim and ride. So basically, you're interested in the 21. Okay. So to answer this question here, wait there, bear with me. So to answer this question, probability of someone who can swim and ride, it would be swim and ride. It would be 21 over the whole population, which is 40. Okay, so this here would be your probability here. You could jump to a calculator and then convert it to a decimal. So here, what is the probability of someone who can swim or ride a bike? Remember, I'm picking out one person at random in your class. So, if anyone in this segment, I'm saying, what is the probability of swim or ride? Well, swim or ride, well, anyone in this segment is able to swim. So this would be a good outcome. Anyone in this segment can swim and ride. So it would be swim. Well, our original probabilities, swim or ride. So this is a good segment. This is a good segment. Anyone from this segment here would be able to ride a bike. So it would be a good outcome here. So basically, swim or ride, it would be this. Hang on. If you want the probability of someone who can swim or ride, well, it's the whole thing here. So basically, if you pick out someone from your class, it's going to be 40 over 40. Swim or ride. So well, that's pretty obvious. So here now here, what is the probability of not able to swim? Well, not swim. Hang on, bear with me. So not swim would be anything inside the circle represents swim. Well, not swim would be anything outside of the circle, and there's only this 8 here. Okay, so probability of not swim would be 8 over 40. Okay, and so draw the Venn diagram, and then from the Venn diagram, from the Venn diagram, you can easily see things and work things out. Okay.